Hello, so in this video I'm just going to talk about the mathematical modelling process. Okay, so modelling is really at the central part of mathematics. You know, one of the reasons why mathematics is so useful in an applied situation, you know, is because you can apply it to so many situations that exist in the world. You know, mathematics is literally the language of nature. And so basically we can use these kind of mathematical modules, we can develop these mathematical models to describe the situation which is going on. And as you know, the general kind of idea is that you start with something quite simple, say, and then you effectively just build on it, right? You just effectively just build on that model to make it more complex. And you know, the more complex you make it, the more accurate you're making it, because the better representation you've got of the situation that you're trying to describe. Okay, and the way which I think of modelling is you think of a Lego model of a car. So you all know what Lego looks like, right? You know, you start with Lego bricks and gradually you just build the bricks up, okay, to represent a model of a car. And so eventually you will end up with something that looks vaguely like a car. Now, of course, this isn't a real car, so you can't get into it and drive it away. But it functions in roughly the same way as a car does, right? It moves, you know, and you know, it moves like a normal car. It looks like a car. It basically will give you the best description you can of a car. You know, it gives you a relatively good description of what a car does. So in other words, modelling, the whole kind of idea of modelling, the key word behind modelling, I suppose, is this word representation. So in other words, you're looking for features that you can represent. In actual fact, sometimes it's not that useful to look at a really complicated model, because everything just kind of becomes so clouded that it's impossible to get information out of it. Sometimes the purpose of a model is that you can simplify a situation dramatically just to get at the heart, or get to the information, or access the information that you need the most. Okay. So, for example, you know, you can look at this model representation of a car, okay, this Lego representation of a car, and for example, you can work out that square wheels won't work. Yeah? So you can use this model to make deductions about real life situations. And, you know, there is a process behind mathematical modelling. It goes like this. So the first thing which you have to do is identify what the problem is. So you have to identify the problem, right? So that's fairly obvious. You know, you kind of identify the thing which you need to investigate. Yeah? Because, you know, that's fairly obviously the first step. You identify a problem and then you build a model out of it to try and come up with a solution. Okay, so the first thing which you do when you're building a model, is you introduce the things which you need to look at. So you introduce variables and parameters. What's the difference between a variable and a parameter? Well, a variable is parameter. Well, a variable, the clue is kind of in the name, you know, variable. Variable. It varies, right? It varies. So in other words, it's a value that it's something which can change, right? It's something which has a value that can change, right? It's an object which has a value which can change. Whereas a parameter is a constant that can take different values in different situations. All right, so the two are very subtly different. A variable is an object that can actively change its value. A variable is an object that can actively change its value. All right, whereas a parameter is a constant, but its value can change depending on the type of situation that you're looking at. So the two are very subtly different. But nevertheless, you know, it's kind of the reason why you want to introduce your variables and parameters. So, for example, if you're modelling. If you want to look at how temperature changes as you put more energy into a system, for example, right? Well, fairly obviously. So if you're measuring how heat changes as you put more energy into a system, for example, or perhaps if you're modelling something like water flow through a particular river, well, then you need to introduce the things which you need to consider, certain things which will affect the thing which you're investigating. So, for example, if you're modelling the flow of a river mathematically, you need to model things like what kind of material is the river going through? Is there any bends in the river? Yeah. You also need to model how fast the water is going. Yeah. All these things you need to think about and you need to consider when you're trying to model a process. Okay. The next step, once you've done this, is to actually form the model. And the nice thing about forming the model is it's normally either an ordinary differential equation or it's a partial differential equation. Okay, because remember that a differential equation is just a description of anything which changes whatsoever. Okay, the whole idea behind differentiation is it's describing change. So a differential equation is an equation which describes change. And in general, when you're looking at models, you're looking at things which change. If things just stayed the same, there's not really much point in forming a model on them. You're usually trying to model. The change or something which change is. All right, and that will be using either an ODE or a PDE. Okay, ordinary differential equation or partial differential equation. Difference between the two, quite subtle. Ordinary differential equation is just if you've got a description of one variable, how one variable changes over a particular time period, for example. A partial differential equation is if you're trying to model more than one variable at a single time. Okay, how more than one variable changes over time. Okay, the two are very, very subtly different, but essentially it's just a form of being a differential equation. Okay, the next step then is fairly obvious. You just need to now try and solve. You need to try and solve the model. Yeah, so you've set the model up. You've considered what the model is in the first. You've considered what the problem is. You've then considered what kind of things you have to consider in the model. You've then set the model up. The next step is then to solve the model. So you either solve the ordinary differential equation or you solve the partial differential equation usually. Okay. Then once you get the results of this out, the next step is to compare your results or compare the model to the real world. So in other words, you get the solutions to your model. And you need to compare those solutions to what you would expect in the real world. Okay, and it's by the comparison of what actually happens in the world. For example, if you form a model and you think, yeah, it's a pretty good model, but the solutions which you get out or the results which you get out of that model are totally different to what actually happens in the real world, then the model's no good. Okay, or perhaps it needs tweaking. So the next step then is to refine as necessary. To refine the model as necessary. Okay, it might not be necessary. The results of this model might be perfectly useful. And might give perfectly good results, accurate enough results that you don't actually need to refine the model any further. But normally, every model needs a little bit of tweaking. And sometimes, if you get a really good model, sometimes the model is working because it's so basic. So the next step is then to try and add another layer of complexity to the model to try and sort of make it more applicable to the real world. Okay. Now, there's two ways that you can refine the model. Either you can refine the model by making more predictions. Okay, so that's kind of the seventh step in model making process. So 7 is either you can make more predictions, okay, on what you might expect to happen. Like I say, trying to add more complexity to the model. This is whole kind of adding more complexity to the model. Yeah, via more predictions. So in other words, you're just adding another layer to the model to make it more advanced. Okay, or you might have to go back and kind of refine some of these further steps. So for example, you might have to go back and you might have to actually introduce more variables and more parameters. So in other words, add an extra layer of complexity to the model in that sense. Yeah, so by adding more parameters and more variables, because normally, if you only consider a very small model or a model with very few variables or very few parameters, you may discover that actually it's not complex enough. In other words, it's too simple. That's why the results which you're getting out are no good, because they're too simple. So sometimes adding an extra layer of complexity to the model. So that's essentially, I'll just make that a little bit smaller. Am I going to fit it in? No, I don't think I am. That is essentially the model making process.